Thank you very much for the kind introduction. I'm so excited to be here. This is my first PyData London, and I'm presenting. It's really good to be here. And thank you all for coming. I wasn't expecting such a large crowd because there's so many interesting talks. Thank you so much. So I'm Sofia. I'm a data scientist at Nesta. I'll talk a bit about Nesta, but just as a bit of a background. So I have a maths and a data science background. Then I did some work in academia, mostly in health. I was looking at road traffic collisions, data, and I also analyzed data from prescriptions. So looking, for example, at whether doctors were over-prescribing antibiotics. So I am really drawn to the social impact. And so then I went to Nesta after that, and I'll talk about my work there today. So in terms of agenda, I'll talk a bit about Nesta and being a data scientist at Nesta. I think it's always good in these talks to also learn about what people do in their sector. So I'm always curious to know about your sectors. So I'll tell you about mine. I'll talk about the project. I'll talk about the working in a secure lab environment and the need for synthetic data. But I'll also go for the methodology, the results, limitations, and applications. And it's before lunchtime, so hopefully it's a nice talk for that. It won't be too difficult to follow, hopefully, and I won't bore you too much. Let's see about that. At the end, I'll also talk about other cool projects that we have and some resources for you, and especially for those who are just starting their data science journey. So Nesta. So what is Nesta? Nesta is the UK's innovation agency for social good, and we design, test, and scale new solutions on society's problems. We have 3 missions. We have the A Healthy Life mission, which focuses on increasing life expectancy and narrowing health inequalities. We have our Fairer Start mission, which focuses on breaking the link between the background of the family and the outcomes of the child. And then we have the Sustainable Future mission, which is where I work. And it's all about reducing carbon emissions in homes. And we do this in multiple areas, for example, by making it easier and more affordable for householders to acquire low carbon heating if their gas boiler dies, for example. That's Nesta. And then being a data scientist at Nesta. So we work in Python, yay, we all love Python. And the cool thing is, so we are a nonprofit and we do all our work in the open. So our code is, almost all of it is openly available. So you can chat that afterwards. And because we are a small team, we work across the whole data science and machine learning life cycle. So we don't just focus on one thing. It's project dependent, so we might be scraping data one day, working on models the other, or creating beautiful visualizations the week after. So yeah, we kind of build a lot of knowledge across the areas. And one good thing about working in a space like this is that we actually participate in the project development. So we as data scientists can come up with ideas and develop ideas into actual projects, which is not the case everywhere. And another cool thing is that it's not just data scientists. It's a multidisciplinary team, and we have data engineers, we have behavioral scientists, we have designers, we have analysts, we have our domain experts in all of our mission areas, and we have policy experts to kind of make contact with reality. So not just doing cool stuff, but actually putting it out there and making it useful. The actual project I'm going to be talking about, using smart meters to identify energy use profiles. So it's all about taking smart meter data from electricity and gas meters and developing what we're calling profiles. Profiles are just groups of households. And then after we have these groups, we can find how they use energy, because those groups are actually built using the energy data. And so we have these energy use profiles. So groups of people who use energy in similar ways, and we then describe the usage patterns, but we can also then bring in contextual information about the demographics, the appliances, and the property characteristics of the households in each profile. And this for us is a foundational piece of work because we wanted to understand how people in Great Britain consume energy, because you can only create policies on top of that if you really understand how people use energy in their homes. So just to tell you about the data source, and just because I always need to say and show this slide. So the data comes from the Smart Energy Research Lab observatory data, and this is only accessible through the Secure Data Service, UK Data Service Secure Lab, and only by accredited researchers. So if you want to access the data, you need to go through these processes. And what is the data? So we have a representative sample of over 13,000 Great Britain households, and they are representative in terms of the region and their income decile. And this is not something common to find. You can find a lot of smart meter data, but not actually representative. And usually the problem is big data. In this case, it's not the case. It's a sample, but actually, but I'll go into that in a bit, actually. So we have this sample of households, and what do we have? We have half-hourly electricity and gas data. So for each half hour, we get the data from the readings to see how much energy they're actually using. And the data starts in 2019. And then we also have contextual information about the households, the demographics, and also the property characteristics of the house, the appliances, and all that kind of stuff. So I just wanted to give a brief introduction into working in a secure lab if you haven't done so. It's not fun, I must say, but they are there for a reason. They are there to protect sensitive and confidential data. And there are a couple of secure environments in the UK, such as the UK Data Service and the ONS Secure Research Service, or the SRS. And for you to access data in these services, you need to be an accredited researcher. So you need to go through some training. It's actually not too difficult to do it, but you need to do it. And I'd say if you're looking into accessing these types of data sets, think about the people that you want to work with on a day-to-day basis, because you can't just have you can just have your data scientists in the secure lab. But that means that the communication between you and your colleagues who are not in the secure lab it just takes longer. So if you're thinking about a project like this, do make sure that your colleagues who are your domain experts also have access to the secure lab. It just makes things much quicker. And also to say, it might take months to access these data sets, so it might take less than that, but just to keep in mind. And you can't disclose all of the information that you want. You can't disclose low counts, no plots with distributions containing long tails. So, we're used to just having open discussions, but when it comes to the secure lab, it's not like that. And just to flag that, the world really needs synthetic data to work on these so important data sets in a much quicker way, and also just to make these data sets bigger, really, by creating synthetic data. So what are we doing, and how are we doing it? So we start with our half-hourly gas and electricity smart meter data. We filter some households because not all of them have data for the period that we want, and we want to make things comparable, so we have to filter some households. And then we need to do a bit more than that. But then in the end, we need to make sure that the sample that we get is also representative. So we need to resample. And then we go into creating a data set of smart meter features. So we do some data cleaning, we do standardization, and we do principal component analysis, and we have our final features that then are fed into our clustering models. We did some model comparison. Just so you guys know, our final model is k-means. But we did try Gaussian mixture models, HDB scan. So, you know, what is that? I don't remember what that definition is. But I know. So there's no free lunch, right? So even k-means can help you solve a problem like this. So yeah, try out even the simpler models. And then at the end, we contextualize each profile with information about the homes and the household. So we create a data set of contextual information, and we aggregate the contextual information into each profile. So just a bit more about the features. So how do we go from half-hourly smart data into actual features that we use in the model? So the data looks something like this. This is not actual data. This is fabricated data. But we have for each household, for each half hour, for each day, how much gas and electricity they are consuming. And we were talking about like this not being big data, but actually for these 13,000 households, if for year data, this turns into over 200 million instances. So it's small in terms of the number of the households, but it's not actually small in the end when you think about instances. So, but what do? We can't use this as it is. So what we do is, with our domain experts, we identified behaviors, lifestyles, and characteristics that impact energy consumption. And for example, if someone works from home, or depending if they have a gas boiler or another type of heating system, or if they have an electric vehicle and it's charging at night, or if they have storage heating, all of this has impacts on their energy consumption. So we identify those behaviors. It's not just these, obviously, this is just an example. And then we map them to potential features, such as the proportion of electricity usage overnight, because if they're charging their electric vehicle at home, they will probably do it overnight, and so we should look at the proportion of electricity at night. And then we get something like this. So for each household, we have a bunch of values for each feature. Easy enough. So how do we go from there into our actual results? So we find the similar groups of households through clustering, as I said before, using our processed smart meter features. And then we can compute all types of patterns, such as, what is the average hourly electricity usage in a year across across a day and across these different seasons. So you can do all of these types of plots afterwards. What I wanted to just say again is that the contextual information only comes in afterwards, because we really wanted to build the profiles only on our knowledge of the smart meter data. So based only on how they consume energy in their homes. So all of the other information only comes in afterwards. Cool, so what is an energy use profile? It's just a group of households that consume energy similarly. And this is also part of what a profile is. It's the proportion of households that they correspond to in the GB population. In this case, we have 3%, so it's a pretty small profile. It's how much electricity and gas they consume across a year. It's also how much they spend. And these are the types of things that we can show. For example, here we're showing across a specific day, what is the average electricity consumption in a specific half hour. And this is, you see basically that there's a peak overnight. And then for gas, you can see that this profile has a very standard gas profile, really, where the consumption goes up in the morning and then at night as well. And then what about our contextual information? So we can bring that in to basically say, actually, this is a group of people who are high-tech and affluent households. They typically have solar panels, they have battery storage, they have EVs, so we see why we have that. Oh, actually, I know, sorry. I just thought the plot really looked really weird from here, but no, it was just from my perspective. Yeah, so we see that overnight peak is actually very likely because they have battery storage and electric vehicles. So it kind of starts making sense. We also know that it's typically large families in detached properties, not in deprived areas, and typically with a high gross annual income, what you expect. And this is kind of really nice, but it's actually not the case for all of the profiles. So, because you can actually go from here to creating what we call an archetype. That's not the case for all of them. So just some insights, and I just wanted to flag that, in data science, we love creating beautiful plots beautiful visualizations, and very fancy. But typically what our colleagues in the policy team need are bar charts or line charts that can tell a story. So I'm sorry, but I'm going to show a bunch of bar charts. But yeah, keep that in mind. Like you can show your very fancy visualizations to your data science colleagues, and they can interpret those. But do keep in mind that, we produce these for the people out there. Well, it depends on your users, really, but you need to know who your users are before you actually show them something, but it should be insightful. So what do we see here? We see basically the distribution of households per profile. We have 10 profiles, and we see that actually the households are not evenly distributed across profiles, and we see that there's different proportions of the population which have different energy consumption behaviors, which is kind of expected. And also I just wanted to flag that the majority of households in those two profiles, 7 and 10, don't consume gas, so it's mostly people on electricity. So the model was able to pick that up, which is actually really cool. So here we have 4 different profiles, and we're looking at the average electricity consumption in each half hour for each of these profiles. And we can see, for example, in profile 1 and profile 8, you can see that it's different, the shape of the curve. So people, but we can see that typically people consume energy in the morning and then at lunchtime, and it goes up in the evening. And so the same for these two profiles, but actually the range is quite different. So the way that we build the features, we're saying that we care about how much they're actually consuming. But we can see that, we can see different profiles. Profile 10 is quite interesting because you can see kind of a cyclic behavior, and that might be because of some other information that I'm going to say after. But yeah, so what are we looking at here? We're looking at the average annual electricity consumption versus the percentage of households in low-income deciles. And although we can't say anything causal, we can observe that clusters with households in deprived areas do consume less electricity on average than those in the least deprived areas. Again, it might be obvious, but you don't know until you look at the data. What else? So here we're looking at the percentage of households on a time of use tariff. So for those who don't know, basically these types of tariffs offer cheaper electricity prices during off-peak hours, and they are typically really good for people who have electric vehicles and heat pumps because they can shift their demand and then they can save money, basically. And what we see is that there are a couple of profiles which have a higher percentage of households on the time of use tariff. And profile 9, actually, 60% of people have an EV, so that makes sense. But there are people who could be saving money and aren't because they are not on the time of use tariff. And then another example here, we have, 22% of people in this profile have an EV, and then 32% have a heat pump, which is a low carbon heating technology. So, I've showed you some insights. What are the limitations? There are multiple limitations to this work, to be really honest. We have the overall small sample of households that, paired with missing contextual data, makes it really hard to then show insights. Just to give you an example, if you have, let's say, you want to look at how many people are in the household. But you have very few missing data. If you have just 2 values of missing data for a specific profile, you won't be able to actually share that. So you'll have to pair the missing columns with something else, which basically means that, for example, you can't say how many people have 3 or more, how many households have 3 or more people in the household, because you'll have to pair that with your unknowns. So this kinds of make it really difficult at times to show insights. And then another thing is that although we see very obvious profiles in terms of energy usage, we were mapping, though, we created the features based on the behaviors that people have. So we kind of expected those behaviors to kind of cluster well at the end, but that's actually not the case all the time. So for example, you might have in the same profile wealthy households with solar panels, because they will consume the energy that they produce, and then they will also export to the grid. So what actually shows that like consumption might be lower, and so they might be kind of paired with people in low-income households. So that is problematic, obviously. And then again, it's easy to say interesting insights about the high-tech profiles, but it's not the same about profiles with people in low incomes. And I also wanted to flag, this is just a version of the truth. We have multiple versions of the truth. The profiles can and should be tweaked to a specific use case. We talked to our stakeholders, and they wanted to do everything. They wanted everything, but you can't have everything. You need to know what your use case is, and tweak the profiles and the feature that you're building based on that. So do we care about how much people are consuming, or do we care about when they use it, or do we care about both? We need to be able to answer these questions. I haven't said actually why do we care about this? So smart meter data is essential in a successful energy transition and in reducing fossil fuel systems. And we need to understand, as researchers and as policymakers, how profiles of energy usage change, how these things change so that we can optimize demand and supply on the grid, on the electricity grid. So analyzing this data and creating profiles like this is really, really important. Just some potential applications. Not necessarily of these profiles specifically, but of this data and this type of work. So identifying people who are underheating and those in fuel poverty. Also, we can offer personalized energy and money saving advice for those who might be able to flex their energy, so when they actually use their energy. Again, as I was saying, the whole thing about the grid load forecasting for peak demand periods, this is really important. Sorry, and then we can also use this to inform policymakers about carbon footprint of different profiles. So these are just some applications, and then again, with our work with our designers, we worked out with our domain experts and designers to kind of go through all of the potential applications. We ran workshops on potential applications. Our designers mapped the applications and the stakeholder needs, and that's a very important work. So it's not about just the data science and doing some cool work. So where are we? We are still in the understanding phase. We wanted to understand energy usage in Great Britain, but we can use this work and do future work to predict where people are in the profiles, and more interestingly, simulate what happens. So what happens as we go from fossil fuel systems to these new low carbon heating technologies. If a person now has a gas boiler and they have a specific profile, where is the next profile if they change to a different system? So yeah, just some food for thought on that. I wanted to say thank you to my wonderful team. So it's not just me, it's all of these people. And I also wanted to give a flavor of the other work that we have, which is really cool. So we have some work on identifying the most suitable low carbon heating technologies in specific areas in Great Britain. And if this is something that, if you like this type of analysis, you can take a look at our code or read our blog about this. We're going to soon release a second version of our calculator to estimate the cost of a heat pump. So again, a heat pump is a low carbon heating technology, and it's not for free, and people need to know how much am I going to pay, given that I have this specific house. So yeah, we have some modeling on that that's going to be released soon, and I'm really excited about that. And then just some previous work that we did. So we looked at posts on online forums, and we basically used those to extract insights about what people were saying when they, for example, want to install a heat pump. Are they facing problems in that journey? What are the problems that they are facing? So we kind of did some NLP work with Bird Topic and LLMs to, oh my God, I said the word LLMs. I swear I was not going to say it. I did. There we go. But yeah, so we did that work, and we have a really cool library to extract skills from job adverts. And then it also maps them to a taxonomy of your choice. And if this sounds kind of, I've heard about this, it's because you have, because my colleagues were here at PyData 2020, PyData London 2023 to present about this. And based on that, so it's a package, you can use it. Based on that, they were also able to measure the greenness of a job, so how green is a job. And yeah, what else? So you can learn from us. We have a Medium blog, and you can just scroll down, and we have, yeah, I'm just gonna say it again, stuff on LLMs as well, and chatbots. But we have a bunch of tutorials, but also just, this was a project that we did, and this is what we learned. So there's a lot in there, and yeah, we just love to put things out there. And then we also give tutorials sometimes. So last month I gave a tutorial on Streamlit, to the app to create some nice dashboards and applications. And we also had one on data labeling using Argilla. I don't know how to say this. But yeah, so we have those. But then the really cool thing, the other cool thing about my team is that we, on a monthly basis, we get together to learn a tool that so basically someone learns a tool, and then they share it with all of us. So they put together some, a short tutorial. So although this is typically for the team, it's online, so you guys can take a look. And we have stuff on Metaflow, for example. I'm not sure if you guys have heard of Metaflow, but basically it's a really easy way to scale pipelines both horizontally and vertically. So there's a tutorial on that. We have loads of stuff, like also Prodigy for data labeling, data profiling, and yeah, all of our code is publicly available. Go check it out. Thank you for listening. I can't believe there's so many people here. Thank you.